I uploaded this video 1 week ago. I click on it and you see it starts with some tables. Well, now I have got a comment here from Andy 4 days ago, and he asks what will happen if I connect an antenna also while doing this test. And that's a highly relevant question, so I will show now what happens. The setup is similar to what it was before. These two generators are set to produce the same signal level into a pair series. They are amplified by these two, this and here, Class A amplifiers. And the amplifiers are followed by 15 MHz low-pass filters going into an iron-free hybrid, and then a matchbox to make sure that very little signal is going from one into the other. It means that the impedance in this port matches what the hybrid wants. And then the signal goes through an attenuator, which currently is set to 0 dB, no attenuation. And from that attenuator into an iron-free directional coupler with about 20 dB coupling. And this, so the signal, the two tones have lost 20 dB when they come out from this port here. The antenna is connected here. It's a 20-meter dipole hanging very low over ground, about 5 meters above ground. And then the signal is passed through this crystal notch filter and finally into the pair series. The pair series screen shows me the two signals. One here and the other here, and I can read on the S meter here level is -10 dBm. I hope the camera can get it. Anyway, -10 dBm. You can see also here where the red scale is. The spectrum analyzer here, it tells me that the level is -9.6 or something like that. So the pair series is well calibrated. There is a very small loss in this cable, which is about 4 meters long, so the difference is only a few tenths of a dB. At -10 dBm, intermodulation is fairly strong. It's here. I click on it and we can read the level. Well, it takes some little time, some integration time. Anyway, we cannot see the noise. There is some, I don't know how to change the gain here. But the level that comes out is -98. That's what Perseus thinks about the third order intermodulation in this situation. And you can see the effect of the notch here. The noise floor is high because of the generators, but on the notch there is no noise from the generators. The noise floor in 500 Hz bandwidth is -125 dBm, or a little bit lower, -125.5. And you see the bandwidth here, 500 Hz. The third order intermodulation product is here. I center it. And now the S meter shows about 3 dB more signal. So this is the point where the traditional measurement of third order dynamic range would place intermodulation in this radio. The attenuator here is 55 dB. So the signal level is minus 65 dBm. That's not much of a signal. Now, this attenuator is on the antenna, so I will turn up something from the antenna to add into the picture. And here we start to see some stations here, but the intermodulation is still visible. So I turn up more. Here it disappears. And we have some activity on 20 meters. The antenna signal is now attenuated by 20 decibels. So it's not much of a signal. So this IM3 is totally irrelevant for any amateur use. So I turn up now with this amount of antenna signal, the intermodulation test in steps of 1 dB. Well, here we have it again at an attenuator setting of, is it so? No, 48 dB. And I increased the antenna signal by 10 dB. And it becomes much weaker. And again by 10 dB, and it is completely gone. So I have to step up the interferers again. Sorry, I do it in 1 dB steps to be sure that I'm not missing something. And it is this place I'm looking. And here we have it. And I have to check at what point it is. Well, I can see on the S meter because the noise floor hasn't changed. This is the true point to measure IM3 dynamic range of this radio. Attenuation is 11 dB, means I have minus 21 dBm as the input signal. I can increase the level by 3 dB. That is 10. So this is 3 dB more, and we should get much more intermodulation. And again 3 dB. One, two, three. 118 to it increases by about 6 dB. 1 step more, 3 dB upwards. And now it is third order, true third order. We have a contribution from noise, of course, also. So to do this properly, I would have to reduce the bandwidth. Now the IM3 dominates in a 50 Hz bandwidth, and the level is minus 104, and I reduce by 1 dB, and it goes down by 3, another dB, 3 dB, another dB, 3 dB again, 1 more dB, now it's 18, and another 1 dB. Now it doesn't go down anymore so much. I disconnect the cable. So this is really the intermodulation signal that is no longer third order. This is something from the ADC probably. This is an attenuation of 7 dB, meaning minus 17 dBm, to see the effect of something that isn't really third order anymore. At higher level than this, what we see is most probably the limitations of the input amplifier. We can compute IP3 for the input amplifier from those 1 dB steps. The dynamic range comes out as the noise floor, minus 125.5, and the point where IM3 reaches the noise floor, that is minus 21 dBm. Now it isn't quite fair, because if I look at the band noise, let's say I go here and restore 500 Hz bandwidth, and have to take some kind of averaging here, I can see that the band noise is quite a bit above that IM3 signal. So third order intermodulation is of no consequence. Band noise should always be a little bit above the receiver internal noise. If it isn't, you need a preamplifier. So this thing, I think, shows very clearly that IM3 is not the important parameter for good modern SDRs, direct sampling units. But of course one should look at it. There could always be a design problem and some nonlinearity in the analog part or something else that has gone wrong.